Hello and welcome to Scientific Supplement Reviews. My name is Dr. Lukas Stadler and I'm a research scientist at the University of Cambridge. Nutritional supplements are everywhere these days and they promise you better health, better looks, more energy and a longer life. But how do you know which supplements actually work and which are a waste of money? Well, I'm here to review the scientific evidence behind supplements and to share my findings with you. Thank you for watching. In today's video, I will review creatine supplements. Creatine occurs naturally in the human body and plays an important role in generating the energy needed to power our muscles. Creatine supplements promise to boost our muscle function, allowing us to work harder in the gym and make faster progress in building muscle and increasing endurance. Here, I will review the scientific evidence to see if creatine actually works. If you're squeezed for time, there's also a shorter version of this video, which provides a brief summary of the main scientific findings. The link to that video is in the description below. Now let's get to it.
Let's start with some background and talk first about the role of creatine in the human body. Creatine is a small organic molecule and an amino acid derivative with an important role in mammalian metabolism. Mammals, including humans, obtain most of their creatine from two main sources, one internal and one external. Endogenously, creatine is synthesized in the liver from amino acids, and exogenously, we obtain creatine through our consumption of animal products, such as meat and milk. Almost all of the creatine in the mammalian body is stored in skeletal muscle tissue, where it plays a central role in the production of adenosine triphosphate, or ATP for short. ATP molecules are the short-term energy carriers that directly power the contraction of muscle fibers. It thus stands to reason that by increasing the amount of creatine we store in our muscles, we might be able to bolster the energy supply to our muscles and consequently improve physical performance. This hypothesis is given further succor by studies going back several decades, which showed that ingesting large amounts of creatine does not result in its excretion from the body, but rather increases its loading into muscle tissue. Historically, creatine supplementation first came to prominence in the aftermath of the 1992 Summer Olympics in Barcelona, after it was revealed that several successful athletes had been using creatine supplements as part of their preparations for the Games. Since then, creatine supplements have become a staple of the fitness industry, with the advent of social media and fitness influencers further boosting the variety of brands and products available. But what, if any, is the scientific evidence to prove that creatine has performance-enhancing properties in humans? To answer that question, I have conducted a thorough review of the scientific and medical literature. Specifically, I looked at 3 different aspects of how creatine might improve performance in athletes. This includes the effect on endurance, the effect on muscle and strength building, and the effect on post-workout recovery. First, let's look at whether there is any evidence to show that creatine supplementation improves cardiovascular fitness and endurance in athletes. As in previous scientific supplement reviews, the most appropriate way of capturing a large number of individual studies that have looked at this effect is by performing a so-called meta-analysis. Meta-analyses pool the results from several clinical studies to obtain a single, combined readout for the effectiveness of a specific intervention. In this meta-analysis from 2023, the investigators analyzed the results from creatine supplementation trials where the test subject's endurance was measured in some form or another. Here, this includes studies that either measured running performance, or conducted a rowing test, or a swim challenge, for example. And here are the results of this meta-analysis amalgamated into one single so-called forest plot. On the left are the references for the individual studies that were included in this meta-analysis, and in the center is a visual representation of the study's outcomes. A black square falling to the left of the dotted line means that the placebo performed better than the creatine in that particular study, and conversely, a black square on the right of the line favors creatine. The black diamond shown at the bottom of this graph represents the combined result of all studies, and in this case, it straddles the dotted line. This means that creatine is no better than placebo when it comes to improving an athlete's endurance. So, no evidence that creatine supplementation boosts one's endurance levels. Next, I would like to look at whether there is any evidence that creatine has a strength or muscle building effect in humans. There are a number of meta-analyses on this aspect of creatine, but in the interest of time, I would like to focus on this very recent scientific paper, which is representative of the entire field. This meta-analysis looked at studies where muscle size was measured before and after a period of creatine supplementation combined with resistance training. In order to achieve an accurate measurement of even small changes in muscle thickness, these studies all used ultrasound to measure muscle size. For this meta-analysis, the authors selected studies that looked at two different muscle groups. As representatives for the upper body, they looked at changes in the size of muscles which are engaged by movement at the elbow joint, i.e. elbow flexors and elbow extensors, better known as biceps and triceps respectively. For lower body strength, they looked at changes in muscle size of the knee flexor and extensor, otherwise known as hamstring and quadriceps. In order to be able to display the data for two muscles in the same graph, in this case for the elbow flexor and extensor, the authors of this meta-analysis decided to visualize the data using a two-dimensional graph, rather than the one-dimensional forest plot which we are used to seeing in meta-analyses. Now, how do we interpret a graph such as this one? Well, the small black circles each represent one measurement from one of the studies included in this meta-analysis. As you can see on the x-axis, the effect size for measurements of the triceps are shown, and any data point that falls into the right half of this graph favors creatine over placebo in terms of increased muscle size. Similarly, on the y-axis, we have the measurements for the biceps, and in this case, any data point that falls into the top half of the graph favors creatine over placebo. Consequently, when a significant majority of all data points falls into the top right-hand quadrant of this graph, as is the case here, we can conclude that, on average, across all the studies included in this meta-analysis, creatine does have a real positive effect on muscle size. And similarly, when looking at the data for the knee extensor and flexor, the authors of this study report that creatine has a positive effect on muscle size for both hamstring and quadriceps. So that means that while there is no evidence that creatine supplementation boosts endurance levels, there is evidence that it boosts muscle size. Having said that, it is important that we put things into perspective in terms of how powerful this supplement is. In the meta-analysis I just presented, ultrasound was used to measure muscle growth. It is important to keep in mind that just because it is possible to detect some growth with a precision measurement such as this, that does not necessarily mean that any difference in muscle size can be discerned with the naked eye. In fact, as the authors of this meta-analysis point out in their publication, quote, "Our analysis of the supplementation indicates that creatine supplementation enhances regional skeletal muscle hypertrophy when combined with structured resistance training. However, compared to a placebo, the magnitude of this effect was trivial to small. As such, the practical significance and implications of this on an individual level are likely small, and that I think is being generous. Alright, now, having covered the effect of creatine supplementation on endurance and muscle growth, let's finish off by investigating the potential benefits of creatine for post-exercise recovery. On this topic, a recent authoritative study is the one shown here. Its findings are interesting, since it shows a difference in the effectiveness of creatine supplementation when comparing exercise-induced muscle damage as an acute training response versus a chronic training response. By way of explanation, let me tell you that by acute training, the authors mean a one-off resistance training session, while chronic is defined as resistance training over a period of several weeks, the latter being the more relevant for most people, I would have thought. So let's delve straight into the data. Here the authors compare the levels of certain blood markers of muscle damage 48 hours after completion of either acute or chronic exercise. Looking first at the effect of creatine on muscle recovery after acute exercise, the analysis finds that across the individual studies investigated, markers of muscle damage are higher in the placebo group compared to the creatine group, as can be seen by the black diamond falling to the left of the vertical line. When it comes to muscle recovery following chronic exercise, the results seem to be reversed, in that higher levels of muscle damage markers are detected in the group that takes creatine, compared to placebo. However, the effect size is very small. Another measure of the extent of muscle damage is oxidative stress. Looking at levels of oxidative stress in muscle tissue 24 hours after completion of acute resistance exercise, the authors find again that oxidative stress markers are higher in individuals who took placebo compared to those who took creatine, thus confirming the beneficial effects of creatine in the acute exercise setting. When it comes to the chronic training response of creatine supplementation, oxidative stress levels are the same in both the placebo and the creatine groups, confirming again that creatine is not effective in this context. So, this then completes the third and final part of this supplement review, with the verdict for creatine's effect on muscle recovery being a mixed picture. It suggests that there is some benefit to muscle recovery following short bouts of acute training sessions, but no effect long term. So, to summarize, is creatine supplementation worth it? Well, what we can say is that creatine has a potentially very small effect on muscle and strength development, and may also help with post-exercise recovery in some very specific contexts. Furthermore, the available data suggest that it is a safe supplement to take. On the whole, however, my impression is that the fitness industry has massively overhyped the potential benefits of creatine, and in most cases, taking this supplement will make no to very little difference to your fitness and visual appearance. It certainly will not make you look like this guy. So, there you have it. I hope you have enjoyed this scientific supplement review of creatine, and I hope it will help you make an informed choice when deciding as to whether you want to purchase and use this supplement in the future. Thank you for watching. Please like and subscribe, and let me know in the comments of any other supplements you would like me to review.